Hey kiddos, it's so good to see you. I thought I would start today off the full screen just to say hi and hope you're doing well. I miss you guys so much. It's just unbearable. I wish we were all in class together still. So, one quick announcement is that our Zoom meeting, which is on Wednesdays at 1 o'clock, I hope everybody can log in this week. You're going to have to check your email the morning of the meeting because that's when I'm going to send out the meeting ID and the password. I used to put it on our website, but people have been hacking into people's Zoom meetings, so I can't do that anymore. So make sure your parents check your email so that you know the meeting ID and the password to get in there, okay? All right, we are going to do, last week I said that that was our last lesson. I was wrong. We have one more lesson and then a test review and then a test this week. So 3 things you got to do. Today's lesson, the test review, and then the test. And that's it. So pretty easy this week. And your Khan Academy, of course. So I need you to get out your blue math notebook and we're going to do a few problems together and then we'll get into our math book, okay? So get your blue notebook out. Pause this if you need to. I got to do this for a second anyway. We'll move it down here and then I'm going to move over here. Open up our math book. Okay. Our problem of the day is right here. So let's read it together. Looking at a group of chickens and cows, so there's chickens and cows in a group, I saw 10 heads and 26 feet. You need to use the guess, check, and revise strategy to solve how many chickens and how many cows I saw. So remember how we did that? You got to start with a guess and then check it and revise it. So pause the video and see if you can figure it out. Okay. So I'm just going to start with my little picture right here. Get my writing tool out. I've got one cow, 1, 2, 3, 4, and one chicken with has 2 legs, right? Here's his little beak. Don't make fun of my chicken and my cow. Okay, so if one chicken has 2 legs and one cow has 4 legs and they both have 1 head, so I can only have how many animals altogether? You know you're only going to have 10 animals altogether. So let's just pretend that we had 5 chickens and 5 cows, just to start. If we have 5 chickens and they have 4 legs each, that would be 20 legs. And 5 times 2 would be 10. So 20 plus 10 would be 30 legs and 10 heads. Oh, we only have 26 feet. So I'm going to take the cow down 1. So let's try this again. Let's say we're going to take, and actually I'm going to do it the other way. My eraser's not very big, is it? Okay. You're just going to have to look past that little thing. Okay, so we have 4 legs on a cow. Let's say we have 4 cows and 2 legs on a chicken. And let's say if we have 4 cows, we're going to have how many chickens? 6. Okay, so 4 times 4 is 16. And 2 times 6 is 12. How many is that? If we add those together, it still would be 10 heads because 6 plus 4 is 10. And 6 plus 2 is 8. And 1 plus 1 is 2. 28. So we went down 2. So it looks like we have to go down 1 more set. All right, let's try this again. Eraser, let's make the eraser bigger. Oh, it erased part of our tail, but that's okay. Okay, so let's say we have 4 times 3. Oh, we don't want it that big. And 2 times what we're going to have 7, right? So 4 times 3 is 12, and 2 times 7 is 14. If you add that together, it's going to be 26 legs. So we'd have 3 cows and 7 chickens to have 26 legs. Let's see if we're right. Let's look at the answer here. Did you guys get 7 chickens and 3 cows? Good job. That's awesome. Okay, let's try this one. This one's a little bit tricky, so you need to pause it and really figure it out, okay? Jessica ran 40 miles in 7 days. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days, right? A whole week. She ran equal distances on Tuesday and Thursday, which was half of her mileage for the week. So let's just stop there for a second. Okay, if she ran a total of 40 miles, right? That's how far she ran in the whole days. And she ran an equal distances on Tuesday and Thursday, which is half of her mileage for the week. So Tuesday and Thursday together, actually maybe we should say plus. Tuesday plus Thursday equals half of 40, which is what? 20. Okay. Great. For the other 5 days, she ran the same distance each day. So how far did she run each day? So I started that for you just a little bit. Now I want you to pause it and try and figure out the rest of it so I know how much she ran every single day. So pause it right now. Good. All right, let's see what you guys got. So if Tuesday and Thursday she ran 20 miles and she ran an equal distance on Tuesday and Thursday, how much did she run each day? So she ran on Tuesday, she had to have run 10 miles. And on Thursday, she had to have run 10 miles. Okay, so how many miles did she have left over? She ran 40 altogether. She has 20 miles left. And so for the other 5 days, she ran the same distance every day. So she has 5 days left. So we've got to take 20 and divide it by 5, those last 5 days, because it was an equal distance every day. What is 20 divided by 5? How many times can we count to 5 by 5 to get to 20? 5, 10, 15, 20, 4, right? So that means that on Monday, Wednesday, Friday, Saturday, and Sunday, she ran 4 miles each day. So Tuesday, Thursday, she ran 10. The rest of the week, she ran 4 miles every day, right? Let's see if we got that right. It says 10 miles Tuesday and Thursday, 4 miles each every other day. Good job. All right, we are going to skip this one. And we're going to go right to here. Okay, what does it mean to partition shapes? We did partitioning earlier in the year. Do you remember what it meant? It meant to divide apart or to cut something into pieces, right? So if you were going to partition the shape into 2 equal pieces, what would that look like? We're going to partition this. Let's make it a little bit thicker. And that means we just divide it right down the middle. That means that we partitioned that shape into 2 equal pieces. And what would those fractions be? This would be what? 1/2 and 1/2. Good job. Great. Now, what if I went like this and I partitioned it into 4 equal pieces? Right? Then I would have it into fourths, so each one would be equal to 1/4, right? Do you guys remember if I have fourths, how do I say half in fourths? How would I say half of this pizza in fourths? It would be 1/4 plus 1/4, which would be 2/4, right? Just a little review for you there. Okay, let's look at this. Chelsea wants to cut this pie into 4 equal pieces or sections. Draw lines to show how she can cut the pie and what unit fraction is represented by one of the slices that she cut. So we kind of just did this. So if we're going to divide it, we're going to partition it. Now remember, when we partition, do we partition like this? Do I say, 4 equal pieces? Is that equal? Does this piece look like the same as this piece? No. So let's think about that. If we're going to partition, if you're going to partition, you always have to make them equal pieces. Now, sometimes our drawings aren't perfect, but in general, you have to be drawing it in a way that would show equal. So if we're going to do equal, we're going to do half and half. So we have equal slices in each one, right? So you can just draw a circle on your page, cut it into fourths. Now, what is a unit fraction? Do you remember what a unit fraction is? If we're saying just one slice, then the unit fraction is going to be 1/4, because a unit fraction is always just saying one unit has a 1 in the numerator, and the denominator is always how many pieces, right? Good. All right. We got that one. Good job. Okay, we're going to do one more problem, and then we're going to get to our book. So let's read this. It says, Marlon has a piece of fabric in the shape of a hexagon. How many sides does a hexagon have? 6, right? Because hex and 6 both are the only ones with an X in it. Draw the hexagon. So let's draw a hexagon. So if we're drawing a hexagon, we are going to have a top and a bottom and 2 sides. Oh, nope, I'm drawing an octagon. Let's try that again. A hexagon. We have to have 3 sides on each one. So if we did 1, 2, 3. 4, 5, 6. I'm doing that wrong. Hold on. You guys, you got to help me draw a hexagon here. I'm having a hard time. Hexagon. I'm thinking of a pentagon, and I'm thinking of a octagon. Why is it so hard to draw a hexagon? Let's see. 1, 2, 1, 2. Oh, there we go. Okay, let's do it like this. 2 sides, and then arrows up like that. Is that right? Let's count it. 1, 2, 3, 4, 5, 6. Okay, it's kind of a funky hexagon. You can draw a hexagon like this too. For some reason, I was just having a hard time drawing one. Right? You have to have a top and a bottom, and then 2 sides that come out as angles. Does that make sense? Because it's 1, 2, 3, 4, 5, 6. Okay, that was funny. Draw the line. Okay, so he draws lines on the fabric from each angle to its opposite angle. Now, you need to draw the lines that he draws. So let's try that. Let's do a smaller thing. So we have to think from opposite to opposite. So if I'm going here, that would be opposite, right? Here, that would be the opposite angle. And here, that would be the opposite angle. So try that. If you're going to draw opposite angle to opposite angle, like the straight across angle and the straight across angle. Good. Okay, then he cuts along each of these lines. What unit fraction represents each piece of fabric? So how many pieces did he break that into? There's 6 pieces, right? So each piece of fabric represents 1/6 of the total fabric. And how many lines did he draw? Just 3, right? Because half of 6 is 3. So each angle went to the opposite angle, so we only had to draw 3 lines and broke it into 6 pieces. Good. Good job. Okay. All right. Let's go ahead and open up your math book. We are going to be on page 871. So pause the video if you need to get that out. Go ahead and pause it. All right. Let's look at example 1. It says, Victoria will plant 4 different vegetables in her rectangular garden. If she wants to partition or divide up the garden into 4 equal sections, what fraction of the garden's area will be used for each vegetable? Draw a rectangle to represent the garden's area. So if we have a rectangle here, and we're going to partition it into how many pieces? 4 equal sections. So remember, if you want 4 pieces, you have to draw 3 lines. Ready? 1, 2, 3. Not totally even, but close enough. Now, if we have a different vegetable, so maybe we have a tomato here, and we have a zucchini here, and we have a squash here. That looks great. And maybe we have some peas here, right? What fraction of the garden's area will be used for each vegetable? So here's a vegetable, and here's one, and they're different. So what is this fraction right here of the whole thing? This square. That's going to be 1/4, right? That's easy. Too easy for you. Okay, let's try the next one. Oh, we already did that one. Okay, that's just the example. All right, if you partition the rectangle into 4 equal sections, we already did that. We explained we drew 3 lines to break it into 4 pieces. And what unit fraction? We already put it down here is going to be 1/4. So you guys can fill in the rest of that page. I just did it all in one piece because I didn't see the bottom. Okay, you partition the rectangle into 2 equal sections. So you could do that if you wanted to. You could divide it into half and then divide each of those halves into 2, right? So you could have a half and then 2 other halves. Or you know that you can just draw 3 lines to make 4 spots. However you want to do that. Okay, partition a hexagon. Let's see if I can draw a hexagon this time. We'll see if we've got it. Okay, so it says partition a hexagon into 6 equal sections. We just did that, so we know how to do it. And then what fraction of the hexagon's area does each section represent? So let's look at it. Remember, we're going to do a top and a bottom. Now, all these sides should be approximately the same size, right? Because all the sides should be the same. And then we draw the 2 little sides to connect. Oh, that just does not look good, but that's just the way it goes for today. Okay, now we're going to divide it into 6 equal sections. So we already know we just go corner to corner because we have 6 angles and 6 sides. And then we have how many pieces? 6 pieces, right? So these guys said we could also do it like this. We could partition it into 2 equal pieces to start. So we could just divide it right in half in the middle like that. right? And then make each one divided into 3. So you could go like this, be like, okay, that's divided into 3 pieces, and that's divided into 3 pieces, right? What if you wanted to go like this, and we divided it into half this way? Can you do it like that? You could do it like that because it would still be even. And then you could say dividing it into, but you know what? Dividing it into 3 equal pieces is a little bit trickier there. How would we do that? It's really helpful to go from the corners because you'd have to kind of divide it into these middle pieces the other way. So I think it's a little bit easier if you plan on, when you're dividing up a hexagon or an octagon or a pentagon, to try a little bit to go from angles first, okay? Now, what unit fraction is one of these pieces going to be? A unit fraction is always going to be what? 1. So we're going to have 1 out of how many pieces? 6. Good job. All right. Let's try the next one. Okay, let's partition this circle into 4 equal sections. Now, a circle is pretty easy when you're doing it this way, and you want to divide it in equal sections because we can just do halfway and halfway. Now, what is the unit fraction going to be for that one? It's really easy. What is it? 1/4, right? If we just have one section right here, that's going to be 1/4. Now, what if we had a circle and we wanted to divide it into 3 pieces? Could I go like this? No, because then they're not even. Those are 3 pieces, but they're not even pieces. So if you were going to divide this into 3, this is where you have to kind of find the middle, and you're going to divide it into sort of 3 big pieces of pie, right? Because those 3 pieces are about the same size. They're pretty close. So that's where you're just going to try and draw a Y. Just kind of like a Y in the middle of the pie, like a wide Y, okay? Just so we can remember how to do that one. All right, we got it. Okay, I'm going to have you guys work on pages 873 and 874. I want you to finish those 2 pages. So you're going to pause this, finish those 2 pages, and then I want you to come back and correct your pages right here to make sure that you got them right, because we do have a test this week, and this will be on there, so I want to make sure you got it right. So practice it, and then come back and correct it. So go ahead and pause it right now. Okay, so this one says partition each figure as indicated. Now, this one's really easy. If you want 6 sections, how many lines do you have to draw? 5, right? You always draw 1 fewer because the ends count as 1, 2, 3, 4, 5. So see how many pieces we have. That's obviously not very even, but we have 1, 2, 3, 4, 5, 6. And the unit fraction is going to be what? 1/6. Good. This one we need 2 sections, so we draw 1 fewer line, right? 2 sections, we just draw 1 line, and each one equals 1/2. Good job. Okay, let's try. Their lines look much nicer than mine, it's true. Let's look at the next one. This one says partition it into 2 equal sections. If I was looking at this one, you could divide it down the middle right here, but to me it seems a little bit easier. Just divide the corner to the corner. Look at how nice and straight that line can be. And then the unit fraction is going to be what? 1/2. Okay, 6. 6 is going to be a little bit tricky because if I did it like this, oh my goodness, that's a horrible circle. But if I went like this, that's 4. How would I make that into 6 pieces? That's going to be kind of hard, right? So let's try this one with the wide Y like we talked about. Because if you have a wide Y, how many pieces do you have? 3. So if I wanted to make it 6 pieces, I would just have to divide each of these by 2, right? 1, 2, 3. There you go. And then each unit fraction would equal 1/6. So that one's kind of tricky. So if you try doing it like this, that doesn't work as well. You got to kind of try and do the wide Y and then divide that into pieces. 1, 2, 3, 4, 5, 6. Good. All right, let's try the next one. Oh, look at this. They divided it corner to corner this way. You could totally do that. That's a way to do it. Okay, number 6 and 7. Actually, I'm going to just, because they divide it better than I do, we're just going to look at the pink lines right here. So this one said divide it into 3 equal sections. So how many pink lines did they draw? Just 2 to get 3 sections. Good. And to do 8 sections, they drew 7 lines, and then they had 1/8 and 1/3 as their unit fraction. So check and make sure you have that for yours. Let's go to the next one. Oh, wait. What is going on? My mouse doesn't want to work. I'm going to have to do it this way. Okay. All right. Let's see how you guys did. If you drew a square and then a rectangle and partitioned it, what would it look like? All right, if you had a square and you partitioned it into 4 equal sections, each unit fraction would equal 1/4. A rectangle into 5 equal sections, each unit fraction would equal 1/5. Okay, let's look at problem solving. Loretta and her 3 friends are helping paint a rectangular wall in the school. They decide to partition the wall into 4 equal sections. Each friend will paint 1 section. What unit fraction of the wall's area will each friend paint? So Loretta and her 3 friends. So if there's Loretta and then friend 1, 2, 3, there's actually 4 of them, and they're dividing into 4 sections. So they're each gonna paint how many pieces? 1. And so if it's divided into 4 pieces, what's that unit fraction gonna be? 1/4. Good. Okay, for number 11, Colton drew a pentagon and he partitioned the pentagon into 10 equal sections. Okay, let's just look at what that would look like really quick. If I was going to, I'm going to have to do it this way. If I had a pentagon always kind of just looks like a house. Oh, goodness. Let's try it again. I'm not as good without my mouse, but it's not working very well. Okay, so we want 10. You know what? We're going to have to look at theirs because I can't draw without my mouse and it's not working. I wonder if it's going to show us the picture. It's not really showing us a picture. Let me see if I can draw it one more time. Sorry, you guys, it's just hard to draw like this. Let me do a little bit of a wider house. Okay, we know that if it was 10 sections and we had one of those, the unit fraction would be 10. But I wonder how we could divide this into 10 equal pieces. How do you think we could do that? What if we went, so this one is going to, if we just divided it in half like this, those 2 pieces would be the same. I don't know how we're going to divide it into 10 pieces. Because if I go like this, are those pieces the same? Well, if it was a true pentagon, these would each be triangles, right? And I would have 5 pieces. 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6. Oh, nope, that's not right. All right. You know what? I'm gonna get in our next lesson. We'll start out with the pentagon and we'll divide it into 10 pieces. Okay? I'll have that drawn for you, so you don't have to look at my bad drawing. And we're gonna divide it into 10 pieces in the next lesson. So you just know that if you divide it in 10 pieces, one of those would be 10. But I'm gonna try and get my mouse to work, and we'll try and do that together at the beginning of our next lesson. Okay? For our review. Let's look at this one. All right, number 12. The area of a rectangular piece of fabric is 24 inches. Ooh, we have a rectangle. So let's draw a rectangle. I think I can do that. Okay, the area is 24 total. So there's 24 equal square pieces inside of here. The fabric book will be partitioned into sections of equal area. Each section will have an area that is 1/4 of the total area. How many square inches will each section have? So let's divide this into 4 pieces. Okay, if this whole area is 24, and you're dividing 24 into 4 equal pieces, we're just going to say, okay, what is 24 divided by 4? What times 4 equals 24? What is that? 6, right? So this is 6 square inches, and this is 6 square inches, and this is 6 square inches, and this is 6 square inches, because the total area is 24 divided by 4 pieces is 6 in each one. Okay, circle the figure for which each section represents 1/6 of its total area. Circle the figure for which each section represents 1/6. So how many pieces is this? 4. Can't be that. How many is this? 1, 2, 3, 4, 5, 6, 7, 8. Can't be that. What's this one? 1, 2, 3, 4, 5, 6. Ooh, that would, a unit fraction would be 1/6. I'm circling that. And that one is only 2, so that one can't work, right? All right, let's check it. Good. We did great. All right, I'm going to let you skip the hot problem for today. If you want to do your homework for extra practice, that's a great idea. I suggest doing that. And I'm going to partition a pentagon at the beginning of the next lesson and go on. We're going to have our test practice, and then we're going to have our test. That's our last two things this week. So I will see you in just a minute.